All right, our next topic is condensation. And since you've made it through evaporation and humidity, you'll be pleased to know that condensation is a pretty easy topic in comparison. First, let's look at where condensation lies in the hydrologic cycle. Condensation takes atmospheric moisture and brings it to the cloud pool. Essentially, we're taking water vapor and turning it into liquid water in the form of little droplets. So in this way, condensation is pretty much the opposite of evaporation. Evaporation takes a liquid to a gas, and condensation takes that gas to a liquid. So here's our definition. Condensation is the process in which water vapor is converted to liquid water. As we noted, it's the opposite of evaporation. Condensation is also a warming process because latent heat is released. We remember that evaporation was a cooling process. As water evaporated, the remaining water was cooled. Conversely, as water condenses, the water body is warmed. We are familiar with seeing visible expressions of condensation all around us. Clouds, fog, dew, steam in the bathroom during a shower, etc. In all cases, for condensation to occur, two conditions must be met. First, the air must be saturated. The air must be at 100% relative humidity. This can be done by adding moisture, but generally it's done by cooling the air. Remember, as the temperature decreases, the relative humidity increases. Secondly, a surface must be present for condensation to occur on. Generally, a surface is almost always present. A surface can be grass or your car in the case of dew, but it could also be little particles of dust or smoke or bacteria in the air. These solid particles in the atmosphere are called condensation nuclei. And the condensation nuclei is the surface on which condensation occurs. So to review, for condensation to occur, two conditions must be met. The air must be saturated at 100, that means at 100% relative humidity, and there must be a condensation nuclei present, a surface for the condensation to occur upon. The surface is almost always present, so really the most important factor is that the air must be saturated. The air must be at 100% relative humidity. We know that relative humidity can increase when the actual amount of moisture increases in the air, but also relative humidity can increase when temperature drops, and this is typically how condensation occurs. As the temperature goes down, the water holding capacity of the air goes down, and the relative humidity increases. So as the air cools, the relative humidity increases. If the relative humidity reaches 100%, condensation begins and clouds begin to form. Cool, eh? Typically, air is cooled to the dew point temperature by rising. Remember, the term dew point temperature is simply the temperature at which 100% relative humidity is reached. Generally, air masses, the only way to cool them to this point is for them to rise. So as the air rises, it cools. We'll discuss this cooling in the next video clip. And as the air cools, the relative humidity decreases. Again, temperature goes down, relative humidity goes up. If the relative humidity reaches 100%, which is also called the dew point temperature, condensation begins and clouds form. Sometimes we can actually see the level that the air has to rise to in the sky for condensation to begin. We call that the lifting condensation level. The air rose and cooled, and at some point it cooled enough that it reached the dew point temperature, 100% relative humidity, and condensation started to occur. Lastly, I encourage you to stop the video and answer these questions. At least answer them orally, but you may even find it's valuable to answer them in writing.